Good morning. Imagine you're sitting in the office to perform your disaster recovery test. We are not sure our disaster recovery test will succeed or not because most of us don't get a chance to validate our recovery plan because of downtime involved in it. What if we have some solution which allow us to perform non-disruptive recovery testing without actually impacting your production, which also allow us to perform end-to-end application validation. So here, what we achieved is we are going to talk about it. With that, I'm Mohammed Kajamoideen. I'm Senior Cloud Infrastructure Administrator with VMware IT. I'm VMware V Expert from 2015 and technical blogging at VMwareArena.com. I have my colleague Karthik Venkatasamy to co-present this session. Let him talk about himself.
Hello everyone. Good morning. My name is Karthik Venkatasamy. I am working as a senior manager in VMware Corp IT team. My team manages VMware business critical application and my VMware portal where customer used to download the vSphere products and the license. Let's continue.
Thank you, Karthik. So what we have in the store is we are going to talk about how big is VMware IT infrastructure and how did we design VMware NSX and Horizon View for this bubble test recovery process. We are also going to talk about the overall process of this bubble test recovery, and also we'll share some of the SRM Advanced Settings which helps us to shorten the RTO, followed by some of the challenges and lessons learned which we faced in this implementation. So this is the snapshot of IT infrastructure. This includes VMware Corp IT and also the OneCloud Infra where your HO labs are hosted. We have around 9 data centers and 117 offices. We have around 1 million virtual machines which are getting created and deleted weekly. We have around 6,000 plus VMware ESXi hosts, and also we are into the container space. We have around 130,000 container space, which is getting created and deleted weekly. We have around 55 production applications which are micro-segmented using VMware NSX, and also 3 production application which is running in VMware Cloud on AWS, which includes VMworld.com, where the web portal which you use to register for this event. On the vSAN space, we have around 10.3 petabyte of raw storage, and also like 73,000 devices which are managed by the AirWatch. So this is like a logical DR design of VMware IT. We have a protected side in the Santa Clara and recovery side in the Wenatchee, and we are using Site Recovery Manager to automate our DR workflows. We have both array-based replication and also vSphere replication to protect our vSAN workloads. SRA is nothing but a storage replication adapter, like storage vendor writes and code, which helps the Site Recovery Manager to talk to your underlying storage during test recovery or actual recovery. Okay, I hope most of us heard about Site Recovery Manager. The Site Recovery Manager is an automated and orchestrated software to automate your DR workflows. It helps us to create a centralized recovery plan for thousands of virtual machines. One of the excellent features of Site Recovery Manager is you can validate your recovery plan without actually impacting the production. So you can test it anytime. And we have a wide range of third-party replication support from storage vendors, and Site Recovery Manager also seamlessly work with vSphere replication. Okay, so as I said, Site Recovery Manager, one of the excellent features is we can test the recovery plan without actually impacting the production. Let's talk about that. So this is a recovery plan. To perform the test recovery, we need to press play button, test. So it will start the test recovery. There are multiple steps involved in the recovery process. First is to synchronize the storage. It will synchronize the active data from your protected site to the replicated site, and followed by restore a recovery site host from the standby mode. So like most of us don't run any active workloads in your DR site. If it is the case, you can make use of VMware DPM to place your ESXi host into the standby mode. But when we perform test recovery or actual recovery, we need the host to power on the virtual machine. So we can define this step ensures that it wakes up your host from the standby mode. and followed by suspend non-critical VMs. So even most of us run non-critical and testing and development workloads on our DR host to utilize the maximum capacity of our hardware. So if you are performing test recovery or actual recovery, so we need a host resources to power on the recovered VMs. So we can define the non-critical VMs to get suspended during this test recovery. So this step takes care of that. Followed by create writable storage snapshot. So whenever we perform test recovery, it creates a temporary storage snapshot from the replicated data store, and it gets mounted to the ESXi host, DR ESXi host. And followed by configure test networks. In SRM test recovery, configure test, the default test network is auto. Auto means it's nothing but SRM creates a port group without any uplink in each ESXi host. So it ensures that the traffic from virtual machine in test recovery will not pass across your ESXi host to ensure that it is not disrupting your production VMs. And followed by power on virtual machine, you can define a priority of virtual machine based on application startup order like app, web, and DB. Also criticality of the virtual machine. Okay, so we run the test recovery and we validated that our infrastructure components, including storage and networks, are working fine. So we can clean up the test recovery. So just press the brush button. So it will start the cleanup. Cleanup is nothing but it powers off the virtual machine and it just resets the storage data. Okay. So now we understand how can we validate our recovery plan without impacting the production is we can make use of test recovery option in SRM to perform that. Okay, now I said with default test recovery network, the traffic will not pass across your ESXi host. But we need to validate the application. In an enterprise scenario, we run a multi-tiered application. So we have to establish a communication across the virtual machines to establish the communication and validate the application. So how can we do that? So we here used VMware NSX to establish the communication across the virtual machines in a bubble test environment. Let's Karthik talk about how did we design that.
Thanks, Mohammed. Okay, we talked about SRM test recovery process. Now I'm going to talk about using SRM, NSX, and Horizon View, how we designed non-disruptive DR test environment. So as we mentioned, our environment is so huge. We have thousands of ESXi hosts and millions of VMs managed by different vCenter servers. When we perform the disaster test recovery, we need to establish the communication across multi-tier application VM, which managed by the different ESXi, which managed by the different vCenter server. So also we need the environment where we can recover all our production VMs into the isolated environment without disturbing our production. So here we are leveraging NSX Cross-vC feature. In NSX, we created a multiple logical universal switches in DR side, which actually emulates our production VLAN. So all these NSX logical switches we have to create in the primary NSX manager, which will get replicated to secondary NSX manager immediately. So followed that, we created a universal distributed logical router, and then one leaf from each NSX logical switch, which get connected to this distributed logical router. So that enables routing access across the logical networks. So when we create an NSX logical switch, it creates as a virtual wire in the vCenter server. So that we map as a test network in SRM. Actually, SRM allows to map various resources like folder mappings, network mappings, and storage profile mappings that can be done at the site level between protected sites and the recovery site to ensure that your inventory levels are matching each other. So like that, like we can map in a network mappings, we can map the protected network, recovery network, and test network, we can map it. When we perform the real disaster recovery, all the VMs will recover into the DR side, and those VMs get connected to the recovery network. When we perform the disaster recovery test, so all the recovered VMs will get connected to this test network. This test network is nothing but our NSX logical switch. This will establish the communication across multi-tier application VMs which spread across into the different ESXi cluster. So look at this logical design diagram where this is our non-disruptive DR test design. So on the left pan you can see that production sites are hosted and where all the production VMs which get connected to the different networks like web tier, app tier, and the DB tier. So these VMs continue to run as it is when we perform the DR test. The business will continue as it is. On the right pan where you can see that this is the recovery side. So where we created multiple universal logical switches, and those logical switches connected to the universal distributed logical router. And these logical networks we mapped as a test network in SRM. So let's see the test recovery here, how the VMs get connected to all these networks. So administrator initiate the test recovery in SRM. So there are various tasks executed. So here we are focusing only the configuring test networks. So during the test configuring test networks, all the recovered VMs will get connected to the isolated bubble network. So followed that, the VMs are powered on. So now we have successfully established the communication for the multi-tier application VM which connect across into the different network. We have not 100% success for our DR test until we perform the application validation. So application validation, since these VMs are recovered in isolated bubble environment, so how can we enable the user access to this bubble environment? So here we are leveraging Horizon View desktop. So that enables the seamless user access to the our bubble network. We need to note one point. So these VMs, all the production VMs which are recovered into the DR side, which is using the same IP as the production. So when user connect to this view desktop by mistake wrongly connect to the production environment and perform the application validation. So how can we overcome this challenge? So for that, we are using a Horizon View security server. So that will be act as this is deployed between the production network and the bubble network. So this acts as a proxy between these two networks. So that will be avoid the risk of the visibility to the production network. Let's see the Horizon View design. So as we discussed, all the production VMs are recovered in the isolated bubble environment, and those are connected to the NSX logical switch. Along with that, we have deployed few View components such as View desktop pool and View connection server inside the bubble. Additionally, we deployed View security server, which has a multi-home network. So one NIC is connected to the isolated bubble environment, another NIC is connected to the user world. So this will act as a proxy between these two networks. Let's see how the user get the View desktop here. The user requests the login to the View pod. The request will send to the connections security server. Security server will forward the request to View connection server. View connection server validate the user request, and based on the user authentication and the entitlement, it will assign the View desktop. Since this View desktop, which is inside the bubble, once user logged into this View desktop, so they can access all the recovered VMs in the bubble environment. So our end user use the Horizon Workspace ONE suite to access all this, all the production application VM. The similar way, they log into the Workspace ONE suite and they access all the production application and perform the application validation. Let me explain about overall bubble test recovery process. As we discussed, we created various network, multiple network switch, NSX logical switches inside the bubble, and these are mapped as a test network in SRM. Along with that, we have deployed a View components inside the bubble for the validation, user access, and the validation. And additionally, we deployed virtual FI load balancer and NAS VMs. These are the physical appliances in the production environment. So here we are using virtual appliance. So FI load balancer used for the load balancing purpose for app and web VMs. NAS VM used for, it serves the NAS exports to all the production VMs. This NAS VM has a multi-home network. So the one NIC is connected to the isolated bubble network, Another NIC is connected to the production environment. So we sync the data from production NAS array to this NAS VM using the production network link. So once the data sync is completed, we'll suspend this link during the DR test. Let's see the overall test recovery process. The SRM administrator initiates the green play button in SRM for a test recovery. So followed that, all the replicated LUNs will get mounted to the DR ESXi host. And then all the recovered VMs get registered to the DR vCenter server. And then it connects to the SRM test network, which is nothing but our NSX logical switch. The VMs are followed that VMs are powered on. So now we successfully established the communication for all our recovered VMs, the multi-tier application VMs, which connect to the different network. The next task for the application validation. So the user logged into the view pod, and once they log into the view desktop, so they can access all the production VM using workspace one suite. They can access all the production application, and they can perform the application validation seamlessly. So we have successfully done the recovery test. During the DR test, we have to continue to monitor the DR journal space on the RPA. So this all the active replications will get written into this DR journal space. If continue to grow, if it is 100% close to 100%, we need to clean up our DR environment. So now Mohammed is going to talk about how we shorten the RTO. Thank you.
Thank you, Karthik. Okay. So now we understand how to establish the communication using NSX, and how did we perform application validation using Horizon View. It is also important how quick we perform our disaster recovery tests. So there are some of the SRM Advanced Settings which really helps us to shorten the RTO. So most of them are related to the array-based replication workloads. The first one is storage command timeout. This is the timeout value for running storage related commands on array-based replication workloads. If you have a recovery plan with larger number of data stores to handle, this default timeout may not be enough. You may receive a storage related errors. So we have increased it from default 300 seconds to 600 seconds, and followed by maximum maximum number of concurrent SRA operations. This is one of the important tasks which allow us to run the parallel recovery of multiple recovery plans. Since we have a larger number of recovery plans, we have to run it parallelly to shorten the RTO. So we noticed in the initial phase when we start the parallel recovery of 4 recovery plans together, so we receive an error on the 4th one. So after reconfigured this setting from default 5 to 90, so it allows us to perform the concurrent operation on the SRA. Next is signature retry, failure retry count. So this is like whenever you perform test recovery or actual recovery in array-based replication, the exact set of LUN is getting replicated to your DR host. So your DR ESXi host sees the existing signature on it. So whenever it gets mounted, it have to perform a resignature to get it mounted to the DR ESXi host. So if you have larger number of data stored in your recovery plan, so that the default retry count is not enough, you may receive errors in your recovery plan. So we increase it from default 1 to 3. Next is host rescan, as similar to the prior one, like whenever you perform test recovery or actual recovery, ESXi host perform and rescan to identify the storage and get mounted to it. So if you have larger number of data stores, then obviously we receive a timeout. So we increase it from 300 to 600 seconds. And next is communication timeout between SRA and SRM. This is specific to the array-based replication workload and EMC recovery point. We are using EMC recovery point for replication. And we notice timeout errors. This is because of the communication timeout between SRA. SRA is storage replication adapter, and SRM. And we work with EMC. We identify the setting called Web Service Connect Timeout. We increase it from 60 seconds to 1860 seconds. You have to edit that in SRA properties file. You need to do that in both your protected site and recovery site. So these are all some of the advanced settings which really helps us to shorten the RTO, so we can run a parallel recovery of multiple recovery plan, which reduces our RTO time. Next, we do have some of the challenges and lessons learned during this testing phase. The first one is like a virtual machine with FT protected. especially multiprocessor VMs. So prior to SRM 8.1, when you perform your test recovery of FT VMs with multiprocessor, you will receive on memory reservation related errors. So you have to configure a memory reservation of the VMs in your DR side, then you have to power on that. With SRM 8.1, it is fully supported FT protected VMs. A slight limitation on array-based replication is nothing but your primary and secondary FT VMs needs to be part of same consistency group. And also after the recovery, your FT VMs will not be FT will not be enabled on the VMs. You have to re-enable the FT. And we have many Oracle rack VMs with shared disk and multi-writer flag enabled. And we noticed this error could not open or create change hacking file when we perform our test recovery. This is because of we enable the CBT, change block tracking, on our disks for the backup purpose. So if you have multi-writer disk, then we have to disable the CBT when you perform your recovery or test recovery. And VDS host errors. This is one of the errors we received when we performed test recovery, and even some of the ESXi hosts got disconnected from the vCenter server. This is because we are running a parallel recovery of multiple recovery plans. The lot of network reconfiguration needs to be take place. Either it configures the test network or even actual recovery. So since we have a lot of reconfiguration task happens, if that particular task takes longer than this timeout value of 30 seconds, which is default one, we notice that the recovery plan is getting failed and ESXi hosts get disconnected from the vCenter. So to avoid that, we increase this rollback timeout from 30 seconds to 300 seconds. After that, we didn't receive any VDS host error. And some of the lessons learned is, as I already discussed, we were not able to perform a parallel recovery earlier due to the limitation of concurrent SRA operation setting. We have configured it from 3 to 90. Then we were able to allow even like 4 or 5, even 6 recovery plans. We are able to parallelly run it. So which helps us to shorten the RTO of our DR test. And obviously, do not share a LAN across your clusters, specifically when you use array-based replication. So you will receive this error, VM first volume cannot found. So do not share a LAN across. If it's some migration purpose, if you're sharing, ensure that it get removed from the LAN after the purpose. This is specific to EMC recovery point. So whenever you perform test recovery or actual recovery, ensure that the transfer state of EMC recovery point is always active. If it is not active, we will receive a storage errors and your test recovery will not continue. If you are not using storage policy-based protection group, whenever you add a new LAN, we have to reconfigure our protection group to include that LAN as part of protection group. Even new VMs is deployed, we have to reconfigure this. Next is whenever you perform test recovery, as I said, when you do the test recovery, it takes a temporary snapshot of your replicated data store, and all the active writes from your protected site will be sitting in your journal log size. So maybe like high write VMs can quickly fill up your journal log size. It impacts the time length of your disaster recovery. So you can monitor the high write VMs. If it is really not needed for your DR test, you can go ahead and power off that VMs in your DR site. Okay, so we talked about some of the lessons learned and issues here. Let's talk about some of the benefits. This is completely flexible and non-disruptive. If you want to perform your DR test, you don't need to run behind your downtime schedule. You can just your production copy is just running as it is. User cannot notice anything on that. You're just validating your application, the entire set, end-to-end application validation in your DR site. It's completely flexible, and with View and NSX, we established the communication, and we have a seamless user validation, so you can perform your end-to-end business transaction. So like every DR test, we perform an end-to-end business transaction, like we send an order and we validate it across all the integrated system, and we validate that order is received till the end. So we were able to perform end-to-end business validation. And update, its infrastructure is keep growing every day. We are adding new softwares, very frequently. So we have to ensure that our recovery plan is up to date as per our infrastructure growth. So this ensures that you are up to date with your infrastructure, and you are frequently testing your test recovery. Next is it's obviously seamless and on-demand DR test. So in our case, like if we have a DR deal which is scheduled over the weekend, so we perform 2 or 3 bubble tests across the week in the weekdays, and we ensure that everything is perfect. If you notice any issues, then we start working on it, because you don't need to get a downtime and get a business downtime for this DR test. We ensure everything is perfect in our bubble test, then we proceed with the DR test. Obviously, it increases your DR confidence. And one of the another use cases, if you have any of the critical application or database upgrade, so there are mission critical, like if it is down, then we will be losing our revenue impact. So what we do is we failover that particular environment into our bubbled environment, and we perform our application and DR upgrades in this bubble environment. We also ensure that we validate the end-to-end application, like business process validation, and then we proceed with the production upgrades. Because we even have a stage and environment, testing environment, but as you guys know, right, not stage is equivalent to the production. We may receive some other different errors in product. So this helps us to ensure that with minimized downtime, we can perform our upgrades without any surprise issues. Obviously, we perform very frequent DR tests, bubble DR test, and it increases our DR confidence. And anytime we can ready and go and press ready for our DR scenarios. And with SRM Advanced Settings, we were able to reduce the RTO, and we were able to perform the recovery of larger numbers within the 90 minutes. That's what the title says. And I hope this is informative for you. And our emails are displayed. You can follow up or send an email to us for any questions.
Thank you.
Thank you.
Thank you. Thank you.